Welcome to today's video on trigonometry. Today we're going to go through some worked examples and we're going to find unknown side lengths, okay? And they might be based on other side lengths as well as an included angle. And we're going to use sine, cos and tan. Okay, starting off, we're going to go through two examples here of using sine, which is on the calculator SIN. So first of all, this is just an example of showing an angle, how it relates to the side ratios. So we've got 30 degrees here, and it turns out with this particular triangle, the opposite side is 1 and the hypotenuse is 2, okay? So then we can actually say that sine theta equals O over H. So we should remember that from last session. And so sine of 30, we replace theta with 30, is going to equal 1 over 2. So we replace the O with 1 and 2 with H. And this actually just equals 0.5, okay? So you're wondering, sine 30, does that equal 0.5? Now let's check this with our calculator. If you put this in your calculator, so sine of 30 degrees, it actually always equals 0.5, okay? So even if we expand the triangle, it will still be the same ratio. So let's have a look at this other example. So we've expanded this triangle now. So it's a similar triangle to the previous one. Now you could probably guess from the hypotenuse being 4 that x should equal 2. Now we're going to solve for x, so hopefully we get 2. This is using algebra now, okay? So what we're going to write is sine of 30 degrees equals x on 4, which is O over H, okay? And x is what we want to find out, okay? Now to find x, we have to multiply both sides by 4 to cancel out the divided by 4. So we get 4 times sine 30 equals 4 times x on 4, which cancels the 4 out. So 4 sine of 30 degrees is just going to be equal to x, okay? Now, so that should almost do it. We do 4 times 0.5. We know that sine 30 equals 0.5 equals x, and we get x is 2, okay? And that's our answer. That's what we expected. So that side is 2. We can use that format to kind of solve any kind of problem with trigonometry, okay? The next one is a cos example or a cosine example, okay? Now this is a little bit different and we're going to use our calculator for this. We're going to draw a really small angle here and we're going to say this is 10 degrees, okay? So we know the angle between is 10. Now x, or the adjacent, is going to be x and the hypotenuse is 20. So we know that cos of theta equals A over H, or adjacent over hypotenuse. So therefore cos of 10 degrees will be equal to x on 20. Okay, now we have to find what that x side is. So to do that, we do a similar step as the previous question. We times 20 on both sides. So we do 20 times cos 10 degrees equals 20 times x on 20. Now the 20 divided by 20s cancel out and we get left with x there, okay? So we can just do 20 times cos of 10 degrees will equal x. Fantastic. Okay, now use our calculator. There's a couple of ways we could do this. One way is to actually work out what cos of 10 degrees is. Now if you put that in our calculator, it's 0.985, okay? Turns out that's quite close to 1. So if we can work out this, so x equals 20 times 0.985. So cos of 10 degrees is just a number, which is 0.985. And then we get x equals 19.7. From the diagram there, 19.7 is very close to 20, so it's a little bit shorter than 20, and so that's the answer we kind of expect, okay? Now, the last question we're going to do here, or the last couple of questions, is a tangent example, or tangent examples, okay? And this is using the tan function, okay? Now, let's have a look at this pretty standard triangle that we might have seen before. It's a 45-degree triangle, so right-angled triangle, okay? The opposite is 3 and the adjacent is 3. And now we know that tan of theta equals the opposite over adjacent, okay? Now, what we've got, tan of 45 degrees is actually going to equal 3 over 3, which equals 1. So even if we expanded that triangle, it'd be 4 over 4, 6 over 6, which always equal 1. So tan of 45 degrees is always equal to 1. That's an interesting little fact there. So tan of 45 degrees is always 1 because the opposite over adjacent is always 1. Okay. Now let's have a look at another tan example. This one is a little bit tricky, and I'll show you a little bit later why. We'll start off with a similar triangle, a different triangle here. We'll make 70 degrees, that one up there, and x is the adjacent now, and 9 is the opposite. Okay, so tan of 70 equals opposite over adjacent. The opposite now is 9, and x is the adjacent one next to the 70 degrees. Okay, so tan of 70 equals 9 over x. So x is now the denominator, or the one underneath the fraction. Okay, so this is tricky now. We have to do a two-step algebra question. So it becomes 2 steps with our algebra. Okay, so here's what we do first. We multiply both sides by x. So we'll do x times tan 70. It's going to equal x times 9 divided by x. Now this cancels out the x's on the right hand side, and we get left with 9. Okay, and this will come in handy for the next bit to solve for just x. Okay, now the next bit is to divide both sides by tan of 70. Okay, now tan of 70 is just a number. If you put it in your calculator, it'd just be another number. So we can divide both sides by tan 70. Okay, so x times tan 70 on tan 70, that will cancel out, equals 9 on tan of 70 degrees. Okay, so we can actually just cancel the tan 70s. Now, using our calculator, we can actually type in 9 divided by tan of 70. Okay, and that'll give us our x value. Okay, which will just be 3.28, and there's our answer. Okay, so we just have to do 9 divided by tan 70, and we get the answer. Okay, so in summary, let's have a look at this. We had 2 types of questions. One was if the unknown, or x value, was the unknown length is the numerator, or the top number. This was for the cos and sine examples. So another example I'm going to put here is sine of 20 degrees equals x on 5. Okay, now all we have to do here is we multiply both sides by the denominator, or the 5 in this particular example. Okay, and then we would actually find what x would be. Okay, so multiply both sides by the denominator, the number under x, and it'll lead us towards x. Okay, so x in there would be just 5 sine 20. Now, if the unknown length, x, is the denominator, or is on the bottom, and I'll show you another example, we might have cos of 40 degrees equals 11 over x. Okay, we have to do 2 steps here. Okay, so the first step will be to multiply both sides by x, okay, on both sides, and that actually cancels out the x on the right hand side, and then we would divide both sides by the sine, cos, or tan kind of value. So in this instance, it would be cos of 40. Okay, so that would lead us towards our answer, x. So we can find x. Now the simple solution there would be x equals 11 on cos of 40. Okay, and that's how we'd find our x value for this particular example. Now, here's a little, just a little piece of information for you. Why was it that sine of 30 degrees was 0.5? I'm not actually going to answer the question for you, but in the comments that you guys will write, see if you can answer this. Okay, here's a little hint. If you've got an equilateral triangle and you split it down the middle, or you equilateral triangle and you bisect it, think about that and you could prove why sine of 30 equals 0.5. Okay, so write that in the comments below if you know how to do that. Thank you for watching today. Please leave any questions or comments below, and if you've worked out why sine of 30 equals a half, definitely let us know in the comments below. As always, thank you for subscribing, and leave your comments. It's always much appreciated. See you later. Bye.